In this section of the course, we're going to cover the basic principles and concepts of cloud migration and cloud computing. As we go through this section, we'll be primarily focused on Domain 2, which is business principles of cloud environments, and Objectives 2.4 and 2.5. Objective 2.4 states that you must be able to identify the benefits or solutions of utilizing cloud services. We'll be specifically focused on cloud-native applications, including microservices and containerization, data analytics, which includes big data, machine learning, and artificial intelligence, subscription services, which includes digital marketing, email campaigns, and social media, and also emerging technologies like autonomous environments and the Internet of Things, blockchain, collaboration, and virtual desktop infrastructure. And Objective 2.5 states that you must be able to compare and contrast cloud migration approaches, including rip and replace, lift and shift, hybrid, and phased approaches. Now, as we begin this section, we will discuss the 3 basic ways you can migrate to the cloud, including moving from an on-premise environment to a cloud environment, moving between cloud environments, or also moving from a cloud environment back to an on-premise environment. Each type of migration has its own set of challenges and considerations, and it is important for organizations to understand these before beginning their own cloud migration project. Next, we'll discuss the phases of cloud migration. Cloud migration is a process of moving data, applications, and other business processes from an on-premise environment to a cloud-based infrastructure, or from one cloud-based infrastructure to another cloud-based infrastructure. This process can be complex and requires careful planning and execution to ensure a smooth transition. During a cloud migration, there are 3 main phases that we will focus on: planning, implementation, and also optimization and security. So we will begin this section by diving into these 3 phases in more depth as we explore the different steps involved in completing each phase. Then we will discuss the 8 types of cloud migration, including rehost, replatform, refactor, repurchase, retire, retain, hybrid, and phase migrations. Rehost, also known as lift and shift, is the simplest and quickest type of cloud migration because it involves moving an existing application from an on-premise or other cloud environment to a new cloud environment without making any changes to the application's code or architecture. Replatforming, also known as lift, tinker, and shift, or re-architecture migration, involves making changes to the architecture of an existing application to optimize it for the cloud. Refactoring, also known as rip and replace, involves breaking down an existing application to smaller, more manageable components known as microservices. Repurchase, also known as drop and shop, involves replacing an existing application with commercially available software as a service or SaaS solutions. Retiring involves discontinuing an existing application and replacing it with a different solution, or simply discontinuing the use of the old product and not replacing it with a new one. Retain involves keeping an existing application as is without making any changes to it. Essentially, you have made a decision to keep your legacy application and continue using it with your traditional on-premise environment. Hybrid migrations involve the combination of different migration types to move an organization's application and data to the cloud. This type of migration can be a good option for organizations that have a mix of applications and data that require different migration strategies. Phase migrations involve moving applications and data to the cloud in stages rather than all at once. This type of migration can be a good option for organizations that have a large number of applications and data, or that want to minimize the risk associated with migration. After that, we will discuss cloud-native applications, including containers and microservices. Cloud-native applications are designed to run on cloud infrastructure and are used to build highly scalable, resilient, and flexible applications that can be deployed on cloud infrastructure. Containers are a lightweight form of virtualization and allows applications to run in an isolated environment. Containers allow developers to package an application and its dependencies into a single unit, making it easy to move the application between different environments. Microservices, on the other hand, are a way of breaking down monolithic or large programs into a single smaller application, independent of services that can be deployed and managed separately. Each microservice can then be deployed and scaled separately based on your organization's requirements. Then we will discuss one of my personal favorites, data analytics. Data analytics in the cloud is really accomplished using 1 or 3 technologies, or a combination of these technologies, including big data, artificial intelligence, and machine learning. Big data refers to large, complex datasets that are generated from various sources such as web logs, e-commerce transactions, social media, mobile devices, Internet of Things devices, and many more. Big data is really characterized by its volume, velocity, and variety, making it difficult to store, process, and analyze using traditional methods. Artificial intelligence is a branch of computer science that deals with the development of systems that can perform tasks that would normally require human intelligence, such as recognizing patterns, making decisions, and solving problems. Artificial intelligence systems can learn, reason, and make decisions based on the data that they have been trained on. Now, machine learning, or ML, is a subset of artificial intelligence that focuses on the development of algorithms and statistical models that allow computers to learn from data without being explicitly programmed. Machine learning algorithms are designed to automatically identify patterns and relationships in data, and then to use those patterns to make predictions or decisions. After that, we will dive into customer-facing services. Customer-facing services refers to the products and services that a company offers to its customers using cloud-based technologies and services. Most commonly, you will find out that cloud-based customer-facing services are delivered under a subscription model. One of the biggest markets for these customer-facing services is in the world of digital marketing. So we'll explore this much more in depth as we go through this section of the course. Next, we will discuss evolving business services, including autonomous environments, Internet of Things, blockchain, cloud collaboration, and desktop management, which is also known as virtual desktop as a service or virtual desktop infrastructure. Autonomous environments refer to the use of artificial intelligence and machine learning technologies to automate and optimize business processes. These technologies can be used to automate tasks such as data analysis, decision-making, resource allocation, and can help businesses operate more efficiently and effectively. The Internet of Things refers to the growing network of connected devices that are embedded with sensors and software. These devices can be used to collect, analyze, and share data, which can then be used to improve business operations, optimize resource usage, and create new revenue streams. The blockchain is a decentralized distributed ledger that records transactions in a secure, transparent, and tamper-proof manner. It consists of a chain of blocks where each block contains a cryptographic hash of the previous block, a timestamp, and transaction data. This structure ensures that once data has been recorded on the blockchain, it cannot be altered or deleted without being noticed. Cloud collaboration refers to the use of cloud-based technologies and services to enable remote and distributed teams to work together more effectively. Desktop management, also called desktop as a service or DaaS, or also virtual desktop infrastructure known as VDI, refers to the use of cloud-based technologies and services to manage and deliver desktop environments to users. Finally, we'll perform a quick demonstration so you can see how these cloud principles are applied in the real world, and then we will take a short quiz to see what you learned during this section of the course. Then we will review each of those quiz questions to fully ensure that you can explain why the right answers were right and why the wrong answers were wrong. So let's get ready to jump into cloud migrations in this section of the course.